Hi everybody, I'll start chapter 15. The important curve, the first curve in this chapter is operating characteristic curve. We will just go over what does that mean. An important measure of the performance of an acceptance sampling plan is operating characteristic curve. So it's an important measure of the performance of one sampling plan. It's important. So this curve plots the probability of accepting the plot, which is PA, versus the lot fraction detective, and that is the small p. There's an example in the book, and it says that we are taking 89 samples, and out of 89, if we have 2 or less than 2 defectives, then we accept the lot. So in order to find the probability of acceptance, we need these values, and then we will draw the also curve. Now, what's the formula? Let's look at the formula. And our formula is PA is equal to P, D is less than or equal to 2. So that's the limits of the defective number. And it is equal to total of n factorial over d factorial in parentheses n minus d factorial times p fraction defective over d, what we found as a defective, times in parentheses 1 minus p over n minus d. So let's calculate an example. And in our example, we have n equals 89 and c equals 2. And we take different numbers as p. And because we don't know what the p is, we don't know the the fraction defective of the lot the company is sending us. So we need to assume that the fraction defective may change from 0 to, let's say, 0.09. And above that, we wouldn't like to accept it as a customer. So we will calculate, we take P equals 0.05 as the first value, and we use the formula here. We say that D is less than or equal to 2. And we add all the possibilities. What are the possibilities? The defective number out of 89 can be 0, it can be 1, and it can be 2. So there are 3 situations which the defective number may take. So let's calculate each of them one by one. Let's say that the defective number is 0. Then when we use the formula here, we say that 89 factorial over 0 factorial times 89 factorial times 0.005 over 0 times 0.995 over 89. So we cancel all these. We know that this is equal to 1, and this is also equal to 1. And we are only left with this value, which is 0.995 over 89 is equal to 0.64. And when D, the defect number, is equal to 1, then the formula is 89 factorial over 1 factorial times 88 factorial, 0.005 times 0.995 over 88. So when we cancel these values, 89 is here. So the calculation result is 0.2862. For d is equal to 2, we write 89 factorial over 2 factorial times 87 factorial. When we cancel these, 88 times 89, and when we cancel 88 by 2 is 44. When we multiply all these, the result is 0.063298. So when we add these three values, we come up with the end result as 0.989688, and in the book it is given as this is approximately equal to 0.9897. We round up 6 because 8 is after 6. So we did this calculation only for 0.05. We repeat these calculations for 0.010, 0.020, 0.030 until 0.090, and we find these PA values, probability of acceptance. And then we draw the operation characteristic curve, which is PA is in the y-axis and P is in the x-axis. P is fraction defective, and PA is probability of acceptance, so we gave equal distances for each value, 0.01, 0.02, 0.03. These are equal spaces here in the x-axis, and again equal spaces for the y-axis. Again it goes the probability. This PA, the maximum value is 1 and the minimum value is here 0. So the probability of acceptance changes between 0 and 1. And when we just put these values in this graph, like 0.05 is equal to 0.9897, it's here. And when we put all the points like this and then draw the line, draw the curve, this is the operating characteristic curve. So for this curve, for example, for 95 acceptable, 0.95, we say that this value here in between is the acceptable quality level. Acceptable quality level. This is actually the customer risk, which is alpha equals 0.05. So this value here is 0.95, and the customer risk is alpha 0.05. So this number here is important. We may be asked to find this number.